All right, let me get these exams back to you. Just put this away. So just come grab these when I call your name. Keegan. Kylie C. Alicia. Jareth. I don't think Jareth is here yet. Cambry. Kylie, the other Kylie. Here, I can just reach over here. Allison. There you go. Let's see, Corwin. Garrett. Raymond. Ashley. And that was it. All right, so let me talk about the exam and the grades. Let me just use my laptop here. I had a little graphs and stuff to show everyone, but shit, come on, man. All right, so in terms of A's, B, C, D, and F, we've taken 3 exams. Exam 1, 2, 3. Your exam's up here if you want to grab it. Put it over here so you don't have to get on camera. Here you go. Let's see. For exam 1, we had 5 A's. Exam 2, 5 A's and 3. So 5, 5, and 3. Then we had 5, 6, and 6. We had 2, 0, and 1, 0, 0, and 1, and 0, 1, and 1. So that just kind of gives you an idea of how many A's we got on the first, second, and third exams, B's on the first, second, third. So we got a pretty big group of students here, about 9. So about 9 of you that are A's and B's. And then we've got a few students kind of jumping back and forth between C's, D's, and F's. The average for these exams, so on exam 1, the average was an 87%. On exam 2, the average was an 88.3%. And on the third exam, it was an 83%. So that's what the averages on the exams were for exams 1, 2, and 3. So overall, I think, like I said in the beginning of the class, I mean, it's as long as you're here, you're doing the reviews, you're doing the homework, I mean, things are going to go okay. Any questions over the exam? I added bonus points today to your grades. So you'll notice in Canvas, you've got grades now for quizzes 1 through 4. Those were homework assignments I asked you to hand in. And then on the exam, you could have got up to a 5-point bonus for an assignment that I had given, I forgot what it was, sketching a rational function. I think that's what it was, but so that's been added. So everything I think that I have from you, I've put in. So if you had any questions over your grades, please just email me, text me. Okay? Any questions? All right. I have an announcement. On Thursday morning, my poor daughter is going to have 4 teeth pulled for preparing her for braces, and they have to take teeth out. I don't get it. But anyways, she's going to have 4 teeth pulled at 8 o'clock in the morning. And of course she's not going to go to school after that. So I would like to do our class remotely on Thursday on Zoom. We've done that before in here, right? The very beginning? Very beginning. So I'm going to send an email out to everyone with the meeting information. And that's just because I want to be able to take her home and care for her in case she needs me, you know. So just FYI. So officially on camera, I'm saying, and then I will remind you with an email. So don't show up Thursday. I won't be here, all right? If you have any issues getting online to do the Zoom session, it's okay. I'll record it, and you can go and watch it some other time, okay? But you will be responsible for the information that I cover on Thursday. So it's not like it's just a free day. Give me a second. I'm just going to go get this wet. Sorry, can I spray it? Okay. Okay, so what are we doing today? What are we doing today? We are going to talk about one of the least favorite ideas or topics in this class from students, and that is logarithms, all right? So let me remind you what we talked about before. We talked about these things called exponential functions. And on the test that you just took, that most of you did very well on, there were 3 questions related to exponential functions. 2 of them were to graph two exponential functions, and then there was the one about the interest, putting money into a bank. So when we studied exponential functions, we said an exponential function looks like f of x equals a to the x, where a has to be a positive number and a cannot be 1. All right, so I gave you examples of this. 2 to the x, right? Different numbers to the x. And then we talked about a very special one, e to the x. And I showed you there was a key on your calculator for that, right? So we've seen these already, okay? So I'll put underneath here, you know, examples that we've seen of this are things like f of x equals 2 to the x. We did a problem where this was like the squares where I folded the paper. That was an example. And then we did like 3 to the x. That was the bacteria problem we did. We even did some with fractions, like 1/2 to the x. That's the one where I tore the piece of paper in half and then tore it in half and tore it in half. And then another example is this one right here, f of x equals e to the x. And this one was the very special one because that number e right here is a special number in math. It's the number 2.718, approximately 2.718. Special number, we won't get into why it's special here in this class. Okay, so we should have some, you know, familiar, I guess, idea of what an exponential function is. So what I want to do now is I want to shift gears and I want us to think about solving equations. Right, this is a big shift. We're going from talking about graphing functions and what they look like to solving equations. So when we solve equations in this class, the types of equations that we've looked at are things that are like linear. Okay, we know how to solve linear equations. An example of this would be 3x plus 1 equals 8. If I asked you to solve this, you would move things around, you get x by itself and get a solution, right? I could ask you to solve a quadratic equation. Okay, and that would be something like this, x squared plus 3x minus 4 equals 0. That's a quadratic equation, and we should be able to solve that in this class as well, either factoring or using the quadratic formula, right? But we have some way of doing it. Notice on both equations, the thing we're solving for, x, appears like down on the bottom. The only exponent we ever see in any of these is that 2 right there, right? But it's the number 2. So I want to introduce you to a new type of equation called an exponential equation. All right? Now, I will put here a check mark and a check mark, meaning we kind of know how to deal with those. But what about an exponential equation? Here's your first example. 2 raised to the x equals 8. So this is an equation, right? This is an equation. Hello, your test is up here if you want to grab it. So this is an equation, right? Because we have an equal sign. Notice where the x appears, right? The x appears up in the exponent, which is why we call it an exponential equation, because the x we're solving for is up on top as opposed to here and here where it's down on the bottom. Now that presents to us a huge problem because we don't have any algebraic way of solving this right now. We can't just like move things around like we did here. We don't have a quadratic formula. We don't have a formula for this. So the question today is, how do we solve this? All right? How do we solve this? So can somebody just look at that and tell me what the answer is? 3, right? 2 to the third power, right? Think about that. 2 to the third power is 8. Why? Because 2 to the third means 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8. So the answer to this, the solution to this equation, is x equals 3, which we can get just by visually seeing that. Do you all understand? If you don't see it, you don't see it, right? But right now, that looks like the only way we can solve it is by noticing that 2 cubed is 8. Got it? So let me give you another one. Okay, let me give you another one to try and solve. So another example of an exponential equation. So how about this? How about 4 to the x equals 16? I'll keep it simple here. So first, that is an exponential equation, right? It has an equal sign. The x is up in the exponent. So can you think what you would have to raise 4 to get 16? 2, right? Does everyone agree? X squared. I mean, sorry, not x squared, 4 squared. So here the solution would be x equals 2. But again, it's a visual inspection, right? Which will start to fall apart pretty quickly. Like, let me give you another example. How about 4 to the x equals 10? Your exam's right somewhere there. You're welcome. Look at that one, 4 to the x equals 10. 4 raised to what power is 10? That's not something that anybody here knows, right? Would you agree that if we try 1, 4 to the 1 is 4, that's not 10, right? And if we try 2, 4 squared is 16, that's bigger than 10. So does it make sense to you that the answer should be somewhere between 1 and 2? But what is it, right? Yeah? So right now, we have no way of doing this, okay? No way of doing that. So we need a way, right? We need a way. Now, let me see. Yeah, I think that'll be it. Let me show you, before we get into how we're going to solve this, let me show you how we could use this idea in a problem. So remember when we were putting money into a bank for a certain amount of time at a certain interest rate, right? I'm going to give you a similar problem. You want to put $3,000 into a simple interest account for, let's go with 4 years. Okay? You've got $3,000. You want to put it into a simple interest account. You want to put it in there for 4 years. All right? What interest rate would you need to have $5,000 at the end of the 4 years. You have your exams I just gave you back, right? If you read the question I gave you on the exam, I told you how much you're going to put in, I told you the interest rate, and I told you how long. And I asked you to tell me how much money you would have after that, right? This is different. I'm telling you how much you're going to put in, I'm telling you how long I want you to put it in for, and I'm telling you how much I want you to have at the end, right? And I'm asking you, what interest rate would you need, all right? So this is the way this formula would work, or this is the way this problem would work. We'd use this shampoo formula, right? And let's just kind of check off the things we know. The P would be the amount we put in, right? We have that. Time, do we know how long we're putting in it? Yes, time we've got. Let me circle these. We know P, we know T, right? Do we know R? No, that we don't know, right? Do we know A? We do know A, right? So let me write this formula out. A would be what for us here? I'm going to leave this here. A would be the 5,000. That's how much we want at the end. So 5,000 must equal the amount we put in, 3,000, right? E raised to the, now we don't know R, do we? So I'm going to leave R alone, but we know T is what? 4, so R times 4 would be 4R. 4R. That makes sense, everyone? And we want to know what R is, right? Yes? Is this an equation? Is the thing you're solving for up in the exponent? Yes. Just like this. This is an equation. The thing we're solving for is up in the exponent. We need a way to solve this. We need a way to solve for R here. We don't have a way. Just like here, we don't have a way to solve for X, other than the visual, right? So does that kind of help you see what the value of being able to solve for whenever the variable's up in the exponent? You see that the value of it is you can actually say, hey, look, I'm going to go shop around, try and find the interest rate I'm looking for, okay? Or you could even change this problem where you have the interest rate, I give that to you, and you go figure out how long you're going to have to leave your money in there to turn it into 5,000. So in other words, I could give you a problem where I don't give you the time, but I give you the rate. So you're trying to solve for time, and then again, the T is up in the exponent. Okay? So how do we do it? Well, I could spend 3 classes talking about, how we do this and get into the technical stuff, but this is the 13-14 college algebra, so we are just going to get right down to the calculator. We're not going to get theoretical, all right? We're not going to bog you down with this. Okay, so take your calculators out. So how to solve exponential equations. All right. So let's go back to the simple, I'm going to do this by examples. Let's go back to the one we started this with. 2 to the x was 8. And Raymond told us that the answer was 3, right? We all said, okay, yeah, that makes sense. 2 cubed, that gives you 8. Let's act like we didn't know that, all right? Let's act like we didn't know that, and let's get our calculators out, and let's do something, all right? All right, the first thing that I'm going to do is there's a key on your calculator that looks like this. It either looks like an IN or like this. Look for that key. It should be the same key that the E was with before. This key, it'll look like one of those probably. This is called the natural log key. It's called the natural log. French, in French, I don't speak French, but in French they do things backwards. So like in French this would be logarithm natural instead of natural log. All right, so That's what it stands for, okay? Now, what does this function do? It does a lot, okay? I'm going to show you with the example. So what we're going to do is this. On this equation, we are going to take this natural log just algebraically and symbolically and just place it on the left-hand side of the equation, okay? And then place it on the right-hand side of the equation. So it's kind of like you're not multiplying by natural log. What you're doing is you are taking the natural log on both sides of the equation. So we are doing something on both sides of the equation which we call taking the natural log. Does that make sense to you? Take natural log of this side, take natural log of this side. Y'all okay with that? Just, yes? Okay. Now, there's a very special property of this natural log, and this is the reason we just did what we did, and that is, whenever you have natural log of something to a power, like this, 2 to the x, you are now allowed to take that x and drop it out in front of the natural log. Okay? You just have to believe that, unless you want me to spend 3 weeks explaining the properties of logs, right? You're just going to take on faith that when you have the natural log of something to a power, you can bring the power out. So my next line looks like this. X times natural log of 2 equals natural log of 8. Do y'all see that x just popped out? This is the power of the natural log. Remember, the whole problem with this is that the x is up top, right? We don't know how to solve when x is up in the exponent. The natural log is what allows us to pull that x out in front. And now what we're going to do is we've got an equation now, right? We've got x over here. It's not up top anymore. So I need to get this x by itself. So what I'm going to do is I'm going to divide the left side of the equation by natural log of 2, and then divide the right-hand side of the equation by natural log of 2. It goes away over here, and what I'm left with is this. X equals natural log of 8 over natural log of 2. This is where I need my calculator, at this point right here. I'm going to get on my calculator. I'm going to put natural log of 8 and then divide that by natural log of 2. Try it on your calculator and tell me what you get. What'd you get? 3. Did you all get 3? Make sure you type it in. You'll have to hit the natural log key twice. Everyone got 3? Hey, wasn't that the answer Raymond told us it was going to be? Now, obviously, you would not want to do this for this problem if you could just look at it and say it's 3, right? Oh, yeah, it's 3. You wouldn't have to go through all this. But remember the problem we were stuck on? We should be able to do this problem now, right? We should be able to do this. Let's try it. Any questions? All right, let's get back to this. So we knew how to do this. Let's try this one. 4 to the x equals 10. Do y'all remember what I said the answer should be between? Our answer should be between 1 and 2. Okay, let's see what happens. So what's my first step here? What do we do? Take the natural log on both sides of the equation. So I'm going to take natural log of 4 to the x equals natural log of 10. All right. The whole point of doing that was to be able to implement this very important property that the x should now be able to pop out in front, right? So now I'm going to pop that x out front. On my next line, x times natural log 4 equals natural log 10. And there's one more step, right? Divide both sides by natural log of 4, right? So divide this side by natural log 4, divide this side by natural log 4, goes away, x equals natural log 10 over natural log 4. Hey. Okay. Okay. Yep. All right. Thank you. All right. So what did y'all get there? Someone tell me an answer. It's probably going to have a bunch of decimals. 1.6. Is that what you got also? 1.66? 1.666?
6609.
Oh, okay. approximately 1.6609 something. We'll just round it maybe 3 decimal places. Hey, we said the answer would be between 1 and 2, right? It's 1.661 something. All right, good. Good. Now, I want you all to try something real quick. See if you can do this on your calculator. Take 4 and raise it to the 1.661. You all remember how to do this, right? How to raise something to a power? Do 4 raised to the 1.661 and tell me what you get there.
10.
Is it 10? It's
10.000.
10.004. So it might be a little bit off, but that's because we rounded. All right? But this is really close to 10. Okay, so we've checked it. We have a way of doing this, right? All right. Let's do another one. You ready for something harder? Let me put, well, no, I think you'll get it. Let's see. Let's try this one. How about this? 3, okay, raised to the 4x minus 5 equals 12. All right, so I've added some complexity to this now, right? I would like for us to solve for x, right? Solve this thing. All right, so you look at this equation, right? You see the thing that you're solving for is up in the exponent. You don't like that, you need to bring it down. So you know you're going to need a natural log to do that. But before you can do it, you have to isolate this term right here. This right here, the thing that's being raised to the 4x, you must isolate this. And what I mean by isolate it is get it by itself on one side of the equation, which means I need to do what first? If I want to get that thing in blue by itself, you're going to add 5 to both sides. Okay, so that's my first step. I add 5, add 5. Okay, it'll go away over here. I'll get 3 raised to the 4x equals 12 plus 5 is 17. Now, do you have something by itself raised to the thing with the variable in it? Yes, right? Now you can bring in the log, the natural log on both sides. So I'm going to bring in the natural log on the left, and I'm going to bring in the natural log on the right. What does this allow me to pull out to the front? The 4x, the whole thing, okay? The whole thing comes out. The whole 4x, not just the x, the whole exponent comes out in front. So my next line looks like this. 4x times natural log 3 equals natural log of 17. Questions there? Let's keep going. What's been the theme here? What do we do on the next step? Yeah, let's try dividing both sides by the natural log of 3. Okay, so let's do that. If we do that here, natural log 3, it'll go away. Over here, natural log 3. We'll have to do that on our calculator, won't we? What is still left on the left-hand side? What's still over there? 4x. Not x, right? 4x. So I have 4x equals, and then on your calculator, someone give me what you get here on this one. 2.5789. Everyone get something like that? Okay, 2.5789. 2.5789. I don't care. 3 decimal places, good enough. Almost done. Almost done. We're back to, you would consider this a linear equation at this point. Trying to get x by itself. Let's get rid of the 4. Divide both sides by 4. So divide 4 here. Divide 4 here. That goes away. You get x equals, and then whatever that divided by 4 is. .644. That's my solution. So think about what this answer is saying. It's saying if I take this number, 0.644, I put it right here. So I do 0.644 right here, multiply by 4, raise 3 to that number, subtract 5, I should get a number close to 12. We're not going to check it, but that's exactly what we found out. See, nobody, look, the first problem that we did, this one right here, you can look at that and tell me the answer is 3. Nobody is going to look at this and tell me the answer is 0.644, right? It's just, you have to have a method, and this is the method, all right? You all happy with that? Let's do another one. This one always gets people, all right? So how about this? You know our shampoo formula has E in it, right? It has E. So let's do one with E. What if I did this? E raised to the negative 3x plus 1 plus 4 equals, let's go with 10. You take a step back, equation, solving for x. X is up in the exponent. I'm going to have to bring a log in. But first, I must isolate the piece that has the x being raised in it right here. I need to isolate that, right? Let's get it by itself. So subtract 4 on both sides, right? Do I need to show that step? Can you all follow what I do here? Subtract 4, right? Now can I bring in the log? Yes, right? Because I have something, right? This is a number. E, you have to remember, E is a number. It's a special number. So that is like what we've had before. A number raised to the thing with x in it. I bring my log in, my natural log. All right, now the property allows me to drop what out front? The whole thing, right? This whole thing, everything here gets dropped to the front. Now, you have to be careful there because when we say everything, there are two terms, right? Negative 3x plus 1. So watch the way I write this. Negative 3x plus 1, right? That's what dropped out front, but because there's two terms, I'm going to place it in parentheses, and then I'm going to have natural log, what's still in here? E, right? Natural log of E. And then equals the other side, which is natural log of 6. Now, I have good news. I have good news. The natural log of E is 1, always. So you can try it on your calculator. It's a little tricky to type in, but try it for yourself. Just try and do the natural log of E and see if you get 1. Are you all getting 1? You got 1? No? Yes? Okay, you did it. All right. So, look, did you get it, Raymond? Yes? Okay. What I would do is this. Just remember this, okay? Just memorize this. Anytime you have natural log of E, it turns into 1. All right? Natural log of E is 1. If it's natural log of 2, well, then you're going to need your calculator. But if it's natural log of E, 1 automatically. All right? So that's a good thing. This just turns into then the negative 3x plus 1. I don't need parentheses anymore because that's just a 1, so it doesn't change this. Equals natural log of 6. Now, do the natural log of 6 on the right-hand side with your calculator. 1.792. Negative 3x plus 1 equals 1.792. Is that okay with you? Approximately, I rounded this a little bit. Now, what kind of equation are you looking at now? Linear, right? Move things around, right? Try and solve for x. So just subtract 1 here, subtract 1 here. You get negative 3x equals what? This will be 0.792. Last step. Last step. Divide by negative 3. So if I divide this side by negative 3, divide this side by negative 3, I get x is negative 0.264. I got a negative answer. Okay, big deal. Anybody have a question? Okay, I think you're ready then for that word problem. Right? So what did we say? We were going to put $3,000, right, in for 4 years, right? At the end, we wanted $5,000. And I asked you to find the rate. I'm just kind of very, very quickly restating the problem I put up earlier, right? And we had set up the equation for it, hadn't we? So look back in your notes. We had the equation 5,000 equals 3,000 e to the 4r. Okay? That was the equation we had, right? So let's see here. Trying to solve for r. R is up in the exponent, so I know I'm going to need a log, but I must isolate the thing that the r is on top of. So I've got to isolate this. The 3,000 is not part of this. There's multiplication here. So I want this purple piece isolated. So how can I get the e to the 4r by itself first? How do I get rid of that 3,000 that's in front of it? Okay, if it was added, I would subtract. But it's not being added, it's being multiplied, which means I'm going to have to divide. Okay? We haven't had to do this before, right? I'm going to have to divide this side by 3,000 and divide this side by 3,000. Questions on that? Does it make sense that you do that? To isolate this piece by itself? Gone, gone. 5,000 divided by 3,000 is about 1.666. I'll go 1.667 is equal to e raised to the 4r. Now what? Natural log, right? The natural log. So I'm going to do it on the left. Natural log of 1.667. Over here, the natural log of e to the 4r, right? What does the right-hand side of this equation turn into? The right-hand side. 4r times natural log of e. Okay, so let me just rewrite this. I've got this 1.667. I've got 4r times natural log of e. But what did we say natural log of e was? 1, right? So really the right side of the equation just becomes 4r. Let's do the natural log of 1.667. This side is 0.511 approximately, equals 4r, because again, that turns into a 1. So the last step would be just to divide by 4, right? And you could get r by itself. So you get 0.127 or 128 equals r. Okay. Remember the question. You're going to put $3,000 into an account for 4 years. You want $5,000 at the end. And I asked you to tell me what interest rate you're going to need to be able to find. So what is our answer as an interest rate? 12.8%. Remember, when you have a decimal as an interest rate, to convert it to a percentage, you have to move the decimal to the right 2 places, which is opposite of what we were doing in the exam problem. So my answer would be 12.8%. I do not think that you're going to be able to find that interest rate anywhere. Maybe the stock market you might be able to, but make sense? Okay. How are we doing here? Just in case anyone came in a little bit late, I know some of you came in after I made an announcement. Thursday, we will not have face-to-face class. It'll be Zoom class, all right? And I'll send an email out to remind everyone. So don't show up here on Thursday. All right, let's see. Just trying to figure out how far I want to push this right now. Let's do this one, okay? You plan to invest $4,000 into a simple interest account at 3.12%. How long will it take to double your money? Simple interest, right? So we know we're using the shampoo formula. Let's talk about the things we have. P. Do we have P? It's the amount we put in, right? We do have this, right? That's P, right? The 4,000 we're going to put in. All right, do we have the interest rate? Yes. The interest rate is given to us. It's actually this, but remember we have to convert it to a decimal. So 0.0312, right? This is R. Do we know the time? No, right? Time is the thing we actually want, right? How long? How long means T, right? And this we don't have. All right, what about A? Do we have A? Yes? How? Yeah, see, we want to double our money, right? We want to double our money. So we want this to turn into what? 8,000. See, we have to think that through. It's not explicitly saying 8,000. If it said triple your money, it would be 12,000, right? So just pay attention to that, right? Because this is given. Double your money means take that, right? Turn that into 8,000. That's your A. All right, let's write the equation down with everything now. This becomes 8,000 equals 4,000 E to the 0.0312 times T. Yeah, I mean, it sucks that your rate is a decimal in front of the T. That sucks, but it's okay. I mean, we'll deal with it, right? Any questions on the setup of the equation? All right, what's first? What's our first step? Isolate it, right? The E part, right? This needs to be isolated, which means we have to do what? Get rid of the 4,000 by dividing it, right? Dividing. So if I divide by 4,000, divide by 4,000, this side's just 2, isn't it? Because we doubled our money, right? If I triple my money, this side would turn out to be a 3, but that's not really important. Okay, that went away. Okay, 0.0312t. All right, once we get to here, we're ready for the logs, right? We bring in the natural logs. Log natural. Okay, has anyone found a pattern of what's happening on this right-hand side every single time we have the natural log and e together? This thing pops out, right? And what happens to the natural log and e? Turns into 1. So all we're going to really wind up with here is this top piece, right? I'll show the work, but that is not a coincidence. That's going to happen every single time. So we are here. We've got, I wonder how long it's going to take to double our money. We have natural log 2 equals, we brought the 0.0312t out. Oh, wait, hold on. Did I mess that? Oh, I'm sorry. I forgot a 0 when I wrote this. Everyone, sorry. See that? 0.312? I did not put that, would be a mistake on my part there. Point. Right? Okay. And then I brought it out, so I still had the natural log of e, which this will turn into the 1. So natural log of 2, let's do that on our calculator. Natural log 2, 0.693, I'll just go with 0.693, equals 0.0312t. Last step. Last step. Get the t by itself by, dividing by, yeah, 0.0312. You got to do that on both sides. 0.0312. Well, it's going to take a while to double our money, isn't it? How long? 22.21-ish, approximately. And do you remember how we measured time in that shampoo formula? Years. It will take you 22 years to double your money if you put it into a simple interest account, right, at 3%. 3% is actually not terrible. 22 years is a long time. Inflation will catch you by the time that happens, right? Right, like 22 years, think about how much a gallon of gas is going to cost. Well, gas isn't a good example. Gas is going to get very expensive once we start running out of it. What do you think? Pretty nice little tool, right? The natural log. Okay. How are we doing here? Good, good. All right, now I want to share with you something. It's going to seem like this is way off topic. So I don't want to lose you here. Don't get like, oh, okay, you know, I'll go check what's on my phone right now. When we look at an equation that's like this, 10 to the x equals, let's say, I don't know, 150. This is just an exponential equation, right? But the base is 10. And there's certain bases that are special, right? 10 to the x, the base 10 is a very important base in our mathematical system. E to the x, if I change this to a different problem, e to the x equals 150. This is a totally different equation, but I already told you this is a very important base. You see we use it in finance for formulas, it appears in there. But the 10 is what I want to talk about specifically right now. Base 10 is extremely important in our mathematical system. And I'm going to try and explain to you why by going back to grade school, all right? So I'm going to write a number on the board here, 3,471. All right, we all have an idea of what that number is, right? So see if this rings a bell. When you're in grade school, you're taught that this is how many ones you have, ones. This is how many tens you have. This is how many hundreds you have. And then this is how many thousands you have. Does that look familiar from grade school? No, no. Right? So if I were to think about this, it's like I had to give you $1 bill, right? I'm going to give you 7 $10 bills. I'm going to give you 4 $100 bills, and then we don't have $1,000 bills, do we? But you get the idea, right? So it's almost like if you give me any, let's say this was 4 digits, any 4-digit number, right? Whatever number you put here is how many ones you have, how many tens, how many hundreds, and how many thousands, right? Okay. What are the possible digits that you can put in here? Like I could put any number I want here. For example, I could put a 1 there, right? What else could I put? 2. A 2. I could put 7. I could put 4. 0. How many options do you have to put here?
10.
There's 10 options, right? There's 10 options. Those options are what? So the options to put here, if you wanted to create a 4-digit number, the options you have for this digit are going to be 0 you could put there, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Those are your 10 options. There's 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the first slot, you have 10 options, right, to put a number there, and that will be how many ones you have. When you get to the second slot, you have 10 options again, right? And that's how many tens you have. And then when you get to the third slot, you have 10 options, and that's how many hundreds you have, and so on and so forth. Making sense? Okay. I'm getting somewhere with this. Just hang tight, all right? So if I wanted to, I'm going to write this number in a completely different way and see if this makes any sense to you. Instead of writing the number 1, I'm going to write it this way. I'm going to say, well, yeah, let's wait on the 1. I'll come back to the 1. On this 7, do you agree I could say this is how many, this is 7 tens, right? Because that's really like a 70, 7 tens. And then this is how many hundreds I have. So this is 4 times 100. That would be 400. And then this one is 3 times 1,000, right? So this is kind of like I was telling you. Another way you could say 3,471 is say 3 thousands plus 4 hundreds plus 7 tens plus, I left this one for the end. How many ones? 1, 1, right? Yes? Okay. Notice this. This is the big thing to notice. This is the big, like, okay. This is the same as 3 times 1,000 is 10 cubed. 10 times 10 times 10 is 1,000. Agreed? Okay. Plus, this is 4 times, this is 10 to what power? 2, right? Squared. Okay. Plus, this is 7 times 10 to what power? 1. And then look at this last one. Plus 1 times this right here, this is a 1, is 10 to what power? 0. The 0 power, because any number to the 0 power is 1. Okay. Now, do y'all see why we like to write our numbers this way? Because this is like really ugly, but do y'all agree this is the same exact thing as this? This is 3 thousands plus 4 hundreds plus 7 tens plus 1 1. Yes? Okay. All of these things, all of these right here are just powers of 10 starting at 0, 10 to the 0, 10 to the 1, 10 to the second, 10 to the third. So let's add one number onto this, okay? I want to add one number onto the front of this. Let's add an 8, okay? Now we have 83,000, yes? Right, 83,000. This would mean we have, let's go straight to this, 8, right? We have 8 what? 10 to the 4ths. 8, 10 to the 4ths, yes? If I put another number in here, like let's say I put 5, I would have 5, 10 to the 5ths, right? This is why we say that our number system is base 10. Because these digits in here are all just representing different powers of 10 and how many of them we have. And we only have 10 options to choose from. All right? There are only 10 options to choose from. So this is, everything we looked at here is what we call the base 10 number system. Base 10. I'd like to show you a different number system. And I could do any base I want. I could do the base 8 number system, but anything. I'm going to do the base 2 number system. And let's see if you can follow this. All right? You got all this? Kind of makes sense? Yeah? I feel like I want to leave it up here. Let me see if I can't squeeze it in right here. Okay? I'd like for us to think about what's called base 2. Okay, so in base 10, how many options did we have for each digit? So I'm going to come over here and I'm going to say, let's try and make a 4-digit number in base 2. In base 10, if I have a 4-digit number, how many options do I have to choose from? 10, right? So in base 2, how many options should I have? Only 2. And that means the only numbers that we're allowed to put in here are going to be the options we have here are 0 and 1. All other numbers do not exist. In base 2, there is no such thing as the number 2. There's no such thing as the number 3. It's like, that's all you know. Sorry, the 1. 0 and 1, that's it. That's all you know. So that's all you can put here is zeros and ones. All right? So you tell me, what do you want here, 0 or 1? 1. What do you want here? 0. Okay, what do you want here? 0. I'll put a 1 here. Okay? What does that number represent? That is not the number of 1001. That's not like over here, right? 1001 would be $1,000 plus $1, right? That is not what that number represents. That is not. It's something completely different. So let's see if you really follow this or not. This first digit tells me I have 1 something to the power. So, right, this first digit 1 said I had 1 of these, right? 10 to the 0. Why did we use 10? Because we're in base 10, right? So this is going to be how many what to the zeros we have? 2 to the zeros. 2 to the zeros. Plus, okay, next digit says I have no what's? 2 to the ones. Okay, plus I have again no 2 to the seconds. And then I know I'm off camera, it's okay. And over here I have 1, 2 to the what? 3. Understand? What is 2 to the third power? 8. What's 8 times 1? 8. That's 8. Plus 2 squared is 4 times 0 is 0. Plus 2 to the first power is 2, but then times 0 is 0. And then plus 2 to the 0 is 1, right? 2 to the 0 is 1. 1 times 1 is 1. Add those all up. What do you get? 9. What I'm telling you is that this number in base 2 is actually the number 9. Right? This number in base 10